All right, let's get into it. Today, we are tackling one of the biggest, most important decisions you can make in software development, choosing the right architecture. We're going to move away from just, following the latest hype and instead build a real, solid, engineering-based way to make that choice.
So how many times have you heard this one? Or something like it? It's that classic line you hear in a meeting that sounds really smart but is a huge red flag. It's a decision driven by trends, not by your actual needs. And honestly, it often leads to just massive, unnecessary complexity. This is the exact trap we're going to learn how to sidestep today.
And that right there, that's what this is all about, the hype trap. It's that moment we choose an architecture because it's popular or it's what some FANG company is using or, hey, maybe it just looks good on a resume. But here's the reality. There is no single best architecture. There's only the right one for your specific situation.
So yeah, let's call it what it is, the architecture hype trap. It feels like a shortcut, but trust me, it almost always leads to a much, much longer and more painful journey down the road. Why? Because when you adopt Netflix's architecture without having Netflix's problems, you don't get their benefits, you just get all of their complexity.
So the whole point of this explainer is to give you a toolkit, a structured way to really analyze what your project needs so you can make a decision that's informed, that you can actually defend. We're going to replace all that guesswork with a clear, repeatable engineering process.
So, what's in his toolkit? Well, it all boils down to a set of 8 critical factors. And by walking through each of these, you can systematically figure out the best fit for your project, your team, and of course, your business. So, let's jump into the first one.
First up, system size and complexity. I love this analogy. Are you building a simple garden shed or a massive skyscraper? I mean, for a simple app, an internal tool, a monolith is perfect. It's fast to build, it's easy to manage. But for a system that's so huge no single person could possibly understand all of it, well, you've got to break it apart into microservices, just like a skyscraper is built from smaller, more manageable parts.
Next up, your team size. You've probably heard of Amazon's famous 2-pizza rule, right? The idea that a team should be small enough to be fed by just 2 pizzas. With a team that small, a monolith is super efficient. But what if you have 50 developers all working in the same code base? You get total chaos, merge conflicts, blocked releases. It's a nightmare. Microservices let those big teams work independently, and because of that, move a whole lot faster.
Okay, let's talk about deployment. A monolith is pretty much all or nothing. You deploy the entire application in one shot. It's simple, sure, but a tiny bug means you have to roll back the whole thing. Microservices, on the other hand, are mix and match. You can update, say, the search service 10 times a day without ever touching the payment service. This gives you insane velocity. But, and this is a big but, it absolutely requires a sophisticated CI/CD pipeline.
Scalability is another huge factor. With a monolith, you usually scale vertically. You just buy a bigger, beefier server. It's pretty easy and often cheaper to start, but with microservices, you scale horizontally. So if your video streaming service is getting hammered with traffic, you just add more servers for that one service without messing with anything else in the application. It's surgical, and it's super efficient when you're at a massive scale.
Now for a really critical concept, and I want you to think about this for your own systems. What is your blast radius?
So the blast radius is basically the total area of impact when one little piece fails. Obviously, the smaller the blast radius, the more resilient your whole system is. The question you have to ask is, how do you contain the damage when something inevitably goes wrong?
And this just illustrates the difference perfectly. In a monolith, a memory leak in some random image upload function can bring down the entire application. The blast radius is 100%. The whole thing is gone. In a microservices world, if the recommendation engine fails, okay, the user just doesn't see recommendations. But the rest of the site, the shopping cart, the checkout, it all keeps working just fine. The blast radius is contained. But, there's no free lunch. Distributed systems come with a cost, and it's often called the network tax. See, every single time one microservice needs to talk to another one, it has to make a call across the network, and that adds a little bit of latency and a whole new potential point of failure. In a monolith, those are just simple function calls inside the same program, which are incredibly fast.
Let's think about the long game here. Maintainability. A layered architecture? Yeah, it's great for just keeping your code organized. But microservices, they offer something way more powerful, replaceability. You can completely rewrite your search service in a totally new language without affecting anything else. It's like being able to swap out the engine of your car while you're still driving down the highway. It's wild.
And finally, maybe the most important factor of all, your business phase should drive your architecture. If you're a startup building an MVP, your #1 goal is speed. Build a monolith and find out if people even want your product. As you grow, sure, introduce layers to keep things organized. Only when you get to that enterprise level of scale and complexity should you even think about paying the microservices tax.
Okay, theory time is over. We have our toolkit, so let's put it to the test. We're going to do a little rapid-fire round here, running through a few real-world scenarios to see how these factors actually play out. Scenario 1, a small web app or an MVP. The choice? Monolithic. Every time. Don't even think about it. Why? Speed is everything. You need to validate your idea, not build some perfectly scalable system for a product nobody wants. Scenario 2, a traditional enterprise app. Here, a layered architecture is often the perfect fit. You've got complex business rules that need to be organized, but you don't have those crazy scaling needs that demand microservices.
Now, for a huge app like Uber, it has to be microservices. You've got thousands of developers, millions of users. You need that independent scaling. For real-time data streams, like from IoT devices, an event-driven architecture is ideal for handling that constant, asynchronous flow of data. And for something like e-commerce, you often see a hybrid approach, super reliable microservices for critical stuff like payments, combined with event-driven patterns for things like inventory updates.
So after all these factors, all these examples, what's the one golden rule you should walk away with?
Here it is. This should be your roadmap. Your default choice for any new project should be a monolith. Start there. As the system gets bigger and you need better organization, okay, evolve it into a layered architecture. And only, and I mean only, when you are facing specific, painful problems with scale or deployment speed or team size, only then should you think about breaking off a microservice to solve that one specific problem.
Look, if you remember nothing else from this, please remember this right here. Your architecture is a tool that's supposed to solve a business problem. Don't pick the shiny new tool first. Understand the problem deeply using the factors we just talked about, and then, and only then, do you choose the right tool for the job.
And that leaves us with one final question for you to take back to your own projects. I want you to look at the system you're working on right now and honestly ask yourself, what problem is my current architecture actually solving? And is it the right one? Thanks for tuning in.